Part 2, Properties of Polynomials. Graphs of polynomial functions are smooth and continuous. That means there are no breaks in the graph. It's continuous, and smooth means there's no sharp corners. It's just smooth all the way through. The leading term of a polynomial function identifies the end behavior of the graph. The end behavior is what's happening on the right side of the graph and the left side. So as x gets bigger and bigger and bigger, or x gets closer to infinity, x approaches infinity, the end behavior is saying what's happening onto the graph there. Is it going up or is it going down? And on the left, as x approaches negative infinity, is the graph going up or going down? And the maximum number of turning points of the graph of a polynomial will be one less than the degree. So if that polynomial has degree 5, the most number of turning points the graph could have would be 4. So if it did have degree 5, we might have a polynomial that has 1 turning point, 2, 3, 4. And that might be a 5th degree polynomial. It has 4 turning points. Notice it is smooth and continuous, keeps going. There's no breaks, no jumps. It's smooth, there's no sharp corners. Let's look at a couple of examples. The one on the left, we have p of x equals a sub 1x plus a sub 0. So we just have some polynomial of degree 1. Polynomial of degree 1, a sub 1 and a sub 0 could be any real numbers. Let's say we have 2x plus 5, something like that. That would be a line. A polynomial of degree 1 does make a line. The end behavior of a graph like this, if we have a line, the end behavior, if the leading term is positive, then on the right, the graph goes up. So this is what this would look like. If the leading term was negative, let's say we had negative x plus 5, then the right side of the graph would go down. So the leading term, if the leading coefficient is positive, the graph on the right side is going up and the graph on the left side is going down. Notice for this polynomial, which is degree 1, the left side is doing the opposite of the right side. The other polynomial we have here is degree 2. That's going to be a parabola. And we know if we have a parabola with the leading coefficient positive, it's going to be going up on both sides. So the leading coefficient being positive means that the right side is going up. And the degree being an even number means the left side is doing the same thing as the right side. If our leading coefficient is negative, it would look something like this, where the leading coefficient is negative, so the right side of the graph is going down. And then because the degree is even, the left side is going the same direction as the right side. Let's look at a few more examples. If we have a degree 3 polynomial, a degree 3 polynomial with a positive leading coefficient could have up to 2 turning points, so it might look something like this. It's going up on the right side if we have a positive leading coefficient, and because it is an odd degree, the degree is 3, the left side is going the opposite direction of the right side. We could have as many as 2 turning points, which is what I drew here, these 2 turning points right here. But if the leading coefficient is negative, then we know the right side needs to be going down, which because it's an odd degree means the left side will be going up. For a degree 4 polynomial, we have a positive leading coefficient. A degree 4 polynomial could have up to 3 turning points, so it might look something like that. If we have a negative leading coefficient, it actually could end up being something that looks kind of parabola-like, something like this. If we have a negative leading coefficient, that means the right side's going down and the left side's going the same direction because we do have an even degree polynomial. Notice here there's only 1 turning point. We said that the number of turning points has to be no more than 1 less than the degree. So a degree 4 polynomial can have at most 3 turning points, but it doesn't have to have 3 turning points. In this case, it has just 1. So you could probably think what the rest of these would look like. An n equals 5, so we have degree 5 polynomial. If the leading coefficient is positive, it's going up on the right, and it's going to go down on the left, because an odd degree means it goes in opposite direction on the left side. And here we have 1, 2, 3, 4 turning points. Degree 5 polynomial can have at most 4 turning points. And then if the leading coefficient's negative, we could do the same thing. Except for now, the right side's going down, the left side's going up. So a degree 6 polynomial, if we have a positive leading coefficient, it actually might end up looking something like this, where it only has, in this case, 3 turning points. It doesn't have to have 5 turning points, but at most 5 turning points. And because it's an even degree function, the left and right side are going the same direction. But if our leading coefficient is negative, we might have something that has 5 turning points. So 1, 2, 3, 4, 5. It might look something like that if our degree is 6. So there's lots of different ways that these can look. We're going to talk about how to decide what's going on, where the x-intercepts are, what's going on in the graph, how we can graph this. The real zeros of a polynomial function. So if we're only talking about real zeros, not imaginary zeros, just real zeros, we are looking at the x-intercepts of the graph. So these statements are all equivalent. 1 x equals a is a 0 of f of x. X equals a is a solution to the equation f of x equals 0. X minus a is a factor of f of x. And a comma 0 is an x-intercept of the graph of f of x. So all of these mean the same thing. If we're only talking about the real zeros, then they can be an x-intercept. If we're not talking about real zeros, the first 3 are all going to be equivalent, but then it wouldn't be an x-intercept of the graph. So for example, if we have f of x equals x minus 2 times x plus 3, then we know that our zeros of the function are 2 and negative 3. Because if I set this function equal to 0, then if x minus 2 equals 0, x is 2. And if x plus 3 equals 0, x is negative 3. So those are our zeros. Those are the solutions to the equation f of x equals 0. X minus 2 and x minus a negative 3, or x plus 3, are factors of f of x. And 2, 0 and negative 3, 0 are our x-intercepts. This is actually what the graph looks like. So we have our x-intercepts at 2 and negative 3, just like we said. The leading coefficient is positive, so it's going up on the right side. Our degree is 2. Each of these factors, you could write having an exponent as 1. So our total degree is 2, which is an even, so the left side is going the same direction as the right side.